Okay, so today, Assalamu alaikum. Today, our class targets for today's class, the topics that we have to cover, mainly from chapter number 4. As we know, that we have covered all these questions of chapter number 3, including the derivations and numericals from the respective chapters, right? Now, today we will be discussing chapter number 4, which is forces and motion. So, we'll be discussing in detail about how these actually work, right? Or Newton's laws of motion. So, if we go here from the concept of the force, we know that the definition is there that force is an agent which changes or tends to change the state of an object from rest to motion or from the motion to rest, or can change the shape or size of an object if it is applied, right? So this is known as force. And for in order to calculate force, we have the formula force is equals to mass times acceleration, and the SI unit of force is Newton. So as we can see here, there are different factors on which force depends upon. Now, as they are saying, there are two factors on which the force depends upon. It is directly proportional to the mass of the body, which means the greater the mass of the body, the greater the force needs to be applied. Okay, so you need to apply a greater amount of force if you are pushing on a heavier object. Secondly, it is directly proportional to the acceleration produced in the body. So greater the force, greater the acceleration. The the this is what the second law of Newton also tells us about, that force is directly proportional to acceleration. Now here, if you can see, we have um, these laws of motion listed here. If we can see Newton's first law of motion, according to this first law, what it says, that if the object is in a state of rest, it will stay in rest. If the object is in a state of motion, it will stay in motion unless acted upon by any external force. Okay? So this is what an example can be: a book on the table, right? For example, the book is stationary on a table, and if you'll not push it or pull it, right, or if you'll not apply a force on it, it will not change its state. So this is what Newton's first law of motion is all about. When we talk about Newton's second law of motion, according to Newton's second law of motion, force is directly proportional to acceleration, which means when the force acts on a body, it produces an acceleration, and this acceleration is directly proportional to the magnitude of the force, as we have discussed.
And
Yes.
what will
Anyone
be the
want?
perfect definition?
Yes. Can you ask your question again?
So what will be the perfect definition for acceleration? If you can define it.
For acceleration, you're asking?
Yes, yes, sir.
Acceleration is basically defined as the rate of change of velocity, right? For example, if you're changing the velocity, for example, you're going on a motorbike, let's say, and if you are changing your velocity, right, by pressing an accelerator, so what you're doing, you're changing your velocity. So this is what acceleration is. It is the change in velocity with
Yes,
respect to time. Okay,
done.
done. Okay.
Yes,
And Newton's third law, everyone is aware about the Newton's third law of motion. An action reaction, we call it, right? So every action has equal and opposite reaction, equal in terms of magnitude and opposite in terms of direction, right? For example, if you throw a ball on the wall, the ball will come back towards you in opposite direction. Okay, so this is what Newton's third law of motion states, right? Inertia is a tendency of a body to resist against the change in its state. So this is known as inertia. Okay, and two examples of inertia can be example number one. If we pull one coin on a card and place a card over a glass and flick the card away with the finger, the coin drops into the glass, right? So this is because of the inertia, right? Another example of the passengers sitting in the bus. If it starts moving suddenly, the passenger will feel a jerk backward in direction, right? So these are some of the basic examples that we have seen of inertia. Basically, inertia is relating with Newton's first law of motion, right? So if there is an MCQ question that comes in your exam, so what you are going to do, you are going to write this. Many times I've seen they've asked that inertia is related to which laws of motion, right? First law, there are options given, of course, in the answers. So you have to select that one option. So Newton's first law is related with inertia, right? So law of inertia
Uh,
is Newton's law of first law of motion.
in
Yes, Abhi, you
in
want to ask
simple
something?
definition, uh, in simple definition of inertia, can we say that a body is getting moved
Come
while
again.
it has not changed its position? For inertia, can we say that the body is getting moved while it is not getting changing its position?
Hmm. Uh, Basically, in very simple words, if you want a one-liner, right, or one-line definition, you can just simply say that it is the resistance against the change in its state. That's what we call inertia. So inertia is the resistance against the change in a state of an object, right? And it totally depends
Okay.
upon the mass of an object. Greater the mass, more will be the inertia. Suppose you are trying to push a bag, a heavier bag, right? It will be difficult for you to push it, right? So this is the thing when you will see, okay, when we can say that inertia is basically related with Newton's first law of motion, and it is like depending upon the mass. So if we move further, so this is kind of a derivation here of F is equals to ma. You can see the steps are quite clearly defined here, right? So I don't think there is any problem. If you have any problem, you can ask. Okay, so the next topic we are going to discuss, and very important topic, is the difference between mass and weight. Now, if we want to say that this is one of the most important difference, because so far what how many guest papers we have seen here, you can see in every guest paper there is a question define mass and weight, right? So this has become a very important sometimes, or not sometimes, you can say most of the times, this question, and very easy to understand as well, right? So the difference between mass and weight, what is the difference between mass and weight? uh, Mass can be defined as the quantity of matter present in a body, whereas weight is the force with which the earth attracts a body towards its center. So that's weight. The SI unit of mass is kilograms. The SI unit of weight is newtons. It is a scalar quantity. Mass, we know that it doesn't have any direction, whereas weight is a vector quantity. So in exam, you basically have to write in uh, two, what you can say, 2 point difference in exam you have to write, right? So just 2 point difference will be enough.
Only two, sir.
Okay. So, okay.
Only two.
Yes. Unless you are asking something, you can ask, please.
Yes, sir. Only two. The difference is on 4 4.
Two difference now, the pattern, as they have changed the pattern from the last year or so. There are two differences that they will ask you, not just one difference. Yeah, if they ask you like previously, they used to ask one difference only. one difference, like write the difference between mass and weight for 4 marks. Now they have changed their pattern, paper pattern, and now rather than asking just one difference between the two quantities, they are asking two differences, right? So for each of the difference, you have to write 2 points at least, right? For example, they have given you the differences of mass and weight, plus they have given you the difference, that write the difference between a small g and the capital G, which is the gravitational constant, right? So in this case, because the question is of worth for 4 marks, you have to write two differences for each of the part. Okay, so this is how you're going to attempt, but it's advisable that at least memorize 3 to 4 points, because sometimes you can miss one or two, right? So then you can make up for that. Clear, Anas? You are
Yes, sir.
answered. Okay, that's good. Okay, so if you can see here, the next question is the big derivation, the long derivation which we'll be doing at the end of this chapter, which is the tension, right? The derivation related to tension force. So we will be moving on further, because this is the part that I will be doing it separately, and I will be trying to shoot a video on this separately, and I will actually upload it with you so that you can understand it more clearly. Okay. Now after that, if you can see, we have another question, a big question, question number 3. What is this question, Habib? Hello.
Yes,
Habib is here with us. Okay. Yeah, Habib, third
yes.
question. Can you see the third question here?
What is momentum?
Momentum and law of conservation of momentum. You know how important this question can be, right? So yeah,
Yes,
this is the third question that we are going to discuss right now. And for this third question, you can see, okay, can anyone tell me the definition of momentum? If I'll ask you, what is your definition of momentum?
The product of mass and velocity, sir.
Yes, excellent. This is one very good answer which can gain you full marks. What about you, Aviv?
yes, sir. Same answer, sir.
Same answer? If you remember, I
Yes,
gave you one more definition of momentum.
the product of
No, 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 not the
weight.
product of. It is defined as the quantity of motion present in a body. Remember?
The,
So
yes,
momentum
sir.
can be defined as the quantity or amount of motion present in a body. That is called momentum. But yes, absolutely, you can write it as the product of mass. If you can see here the definition, you can see my arrow here on the screen.
The quantity.
What they are saying, the
Yes, sir.
quantity of motion contained in a body is called momentum, and it is denoted by P, and it is a vector quantity, right? So if you can see the formula, P is equals to mv. So stands for mass, and V here stands for velocity. The SI unit will be kilograms meters per second,
One
or
second.
newtons second, right? So another unit can be newton second. Factors depending upon torque, so it is directly proportional to the mass of the body and velocity of the body. You can see here.
This is so did you send the link of this
Of what?
in group?
These
Did you send me the link of this in group? This page.
for what? Which link? Notes?
Paper. This case paper.
Yeah, I will share you. Don't worry. I will share in the group, and I
So
will
you can
add all those students here also, who are actually taking the classes now. And I will ask Fezullah Saab also that try to remove those students who are not interested in it, right? So they will be removed from the group.
You
Okay.
should add me.
Yeah, yeah, you will be added. You, Rashid, will be added. Rashid is not here, surprisingly, today in the class, but you will be added. I've seen your number. You will be added soon in the group. Okay, so yes, if you can see here, so this is the question and this is the answer, that the law of conservation of momentum, it states that then the total momentum before collision must be equals to the total momentum after collision, right? So the total momentum here remain conserved, right? And you can see this quite well that according to law of conservation of momentum, the total momentum stays conserved, right? It is not changing as the total momentum before the collision, which is m1u1 plus m2u2, and momentum after collision, which is m1v1 m2v2. Now if you can see here on the screen, this u1 and u2, right? This is representing initial velocities because it is before collision, and v1 v2, it is our final velocities representing after collision scenario, right? So any doubts here?
No, sir.
No, sir.
Okay, okay, let's move forward quickly. The next question that we have to cover is yes, friction, right? This is the generalized equation. If you can see again here on the screen, this is the generalized equation of total momentum for collision must be equals to the total momentum after collision, which states m1u1 plus m2u2 is equals to m1v1 plus m2v2, right? So this is very important as far as this question is concerned. Okay, and friction now. Okay, because the next question that we have to target is friction. If you can see, yeah, they are saying write down the differences, different types of friction. Also write advantages and disadvantages of friction and write some methods to reduce friction. So these are making two questions as you can see, and we have already discussed them, right? So if we can see here, the friction is what basically when the two bodies are in contact with one another and they move against each other, right? So this is known as friction, right? Or the force between the bodies which are moving towards one another is known as friction, right? So if you can see this friction, Fs is representing the static friction, so or limiting friction basically here. So this is representing that it is directly proportional to R. What is R here in the formula or in the relation here? If you can see, it is representing the normal reaction force, right? And this is equals to weight if I want to write it here. So this R, normal reaction force, is always equals to weight, and this weight is equals to mg, right? So this will sum up, and if you can see here, if you want to go from a relation that sign to equal or equation, you have to change it with the equals, and there is a constant which is called the coefficient of friction, right? So this is the formula of friction here, all right? So yes, if you have any doubt, you can ask here, right this point.
No, sir. Clear.
No, sir. Friction all clear.
Friction all clear? Okay, so let's
Yes.
quickly go overview on the remaining part of friction, as they are saying the advantages and disadvantages, right? First, factors on which friction depends. So friction depends upon two things. The two main things the friction depends upon: the nature of the surfaces and normal reaction force, right? So it is directly proportional to that. The more rough the surface is, uh, the more the friction will be. The more the slippery surfaces, the less will be the friction, right? So you have seen that if there is a wet floor, so there are greater chances that you might slip, as compared to a rough surface, right? So it definitely depends upon the nature and then the normal reaction force. Types of friction: static friction, in which the object is not moving. Kinetic friction: the friction occurs between the body when the object is in motion, right? So if they're saying friction during the motion is also known as kinetic friction. Sliding friction is also uh, sliding friction is also uh, when they are saying over sliding over a surface. For example, the water slide, right? When you'll go into the water park, you know that there is some sliding friction on the water slides. And then the rolling friction, another type. So they're saying when a spherical body rolls on a surface, so the friction of force which exists during the motion is called rolling friction. Example can be a ball rolling down from a hill.
Football, football.
हाँ, और a stone आपने you have seen that कि the stone sometimes it's falling from the top of the mountain, right? So this is
Yes,
again an
sir.
example of a rolling friction. Okay, then limiting friction. What is the limiting friction? Limiting friction. Okay, remember these. If let me circle here. Let me just highlight this portion. Mm, okay, these are shapes we have found. Okay, so if you can see here that this one limiting friction mainly. This will come in the exam, or this question in the definition they have asked it for many of the times, that what is a limiting friction, right? So if you'll define the limiting friction can be defined as the maximum friction or the maximum value of resting force between the two surfaces before the motion starts the static friction. This is called limiting friction. Or further we can say that the point where the static friction becomes zero, the maximum amount of friction, that point is known as the limiting friction. Okay. Okay, now let's move on towards the last part of this, like advantages and disadvantages of friction. So I will ask from you people, right? You have to tell me, both of you separately have to tell me about two advantages of friction and two disadvantages. Yes, two advantages or two disadvantages. Yes, first of all, Anas, can you tell me about the two advantages of friction?
Yes, sir. This is
Yes.
given that friction enable us to walk on the ground. If there is no friction, we slide over the ground, and friction enable us to walk on the ground.
Okay, Habib, what about you? Other than these written here on the board. Okay, can you say that again?
Sir, a nail stays in a wood due to friction, and a nut bolt can hold a body due to friction. And
Yes,
sir,
advantages can be that we can walk easily on the ground with the help of the friction. Some of the like belts on a motor can move easily, right? Without, if there is friction, like, so the motor parts will not be moving. Or we can say that, as they are saying here, that the if the car is able to move, or the car is going smoothly on the ground, because there is sufficient friction between the tire and the ground. So if there is no friction, the car or the bike literally slips down, right? So these were some of the
yes,
advantages of friction. And when we'll go on to the disadvantages part here, so disadvantages of friction, which means that, yeah, wear and tear, this is the biggest disadvantage, means the things get roughed up and then they loses a lot of energy, and wear and tear of parts, as we have discussed also. Further, how we can reduce friction. So there are methods simply that we can reduce friction through. We can use some ball bearings or various parts like oil, various things like grease. We can grease them, we can lubricate them, or we can oil them, so in order to reduce friction, right? So yeah, these are a couple of methods in order to reduce friction. So this was it actually today for the lesson.